Hello, I am speaking to you, my SNO students, in this physics makeup class. I'm going to go ahead and make this video. I'm assuming there's no school on Friday. As I said, on Wednesday, if there was no school on Thursday or Friday, we would go ahead and have a makeup physics class on video. So this is it. So hopefully you're comfy and warm and safe, and if you're watching this you have electricity, so that's a good thing. We've got about, looks like over a foot of snow. It's like 10 o'clock here on Thursday morning, and it looks like it might be sleeting right now, so we'll see what comes of the rest of our day. Before I teach the new concept, I just want to mention some lab blab, and that some of you are actually handed in your labs, and if I say anything that causes you to want to change anything on those labs, you may get them back. I believe I checked them over though and they were fine, but just to recall that they are due a week from our last class. So I guess we met on Wednesday, so what's that, next Wednesday the 19th, I believe. So we always take a week after the lab is finished to write it up and get it in. So make note of that. And it's not a full-fledged lab write-up. It's just 2 graphs, the results, and the calculations, all the calculations. I want to see your calculation for every velocity. So there should be 7 or 8 velocity calculations to show me, including units and so forth. I'll mention, just a brief mention about the graphs. They should have a title on each graph and units on the bottom and the axes labeled. I mentioned this already, and it is actually on the lab itself. It explains in detail on the second page of the lab how to do the graphs. So I mentioned it several times in class, but if you have forgotten, it is written out for you. The results section is the only thing I want to mention right now, and just to remind you what I said about that, all I'm looking at is I want you to compare what you saw in lab to what you expect mathematically. So remember, our main player for this mod is this formula, force centripetal, right here, mv squared over r. So that will dominate our discussion for the whole mod. And in lab, let me see if I can get some better lighting. All right, hope there's not too much glare with that. So in lab, in the first part, if you recall, we added hanging down washers, 1, 2, 3, and 4. Those were causing more tension on the string, which is an increase on the force centripetal. And so this was going up. The mass, that was the little ring that the single washer that we were spinning stayed the same on each trial. The radius on part 1 stayed the same. It was 0.48 meters. So the question is, what happens to velocity in this case? So mathematically, these sides have to be equal. These remain the same. This increases, so what must this be doing? So in the results section, tell me mathematically what you think should be happening, and then what you saw in lab actually happening. And if they are not the same, discuss why that might be. In the second part of the lab, we changed the radius. The radius was going up, 0.12, 0.24, 0.36, and 0.48. This time we had 2 hanging down washers, so the force centripetal was the same on each trial in part 2. So this stayed the same, the mass that we were spinning stayed the same, and the radius was increasing. What happens to velocity this time to keep these equal? So this is not changing, this is changing in the upward direction, so what must this be doing to keep it the same number over here? So that's what you're discussing in the results section of the lab. All right, that's enough of lab blab, and to our theory for today. We have discussed force centripetal, and that is the force that causes any circular motion. And it is not a mysterious force, but it's actually provided by forces that we have studied. And one of those, when there's a string involved, is tension. So, and when a string is involved, we use this formula, replacing force centripetal with tension. However, for example, if a bike is going around a circle, what is it? Blank equals mv squared over r. And let me remind you at this point, if you are watching this video, to get credit for it, you must take notes, hopefully in your comp book. If not, any old paper will do. So here in this scenario where a bike is going around the circle, what other force that we've studied is providing centripetal force? Morgan. I keep asking you this. I bet you knew it. Let me see. Yes, you're right. It's friction. And I'm just going to replace this side with the formula for friction. And that is mk, because our object is moving, mg. It's actually mk force normal, but mg will, force normal is mg in this case. So we've got two scenarios, and on the green handout, which is due when we get back to class, you had to use this one or this one. I think this one was the star of the green handout, and this one I think you only used once. I'm not sure, but if there was a string involved, you were using this one, and if there wasn't, if it was an object, a truck or a bike or a vehicle going around the circle, you would use this one. However, I remember the last one on the green handout. Let me give you a clue about that. And that is that one where they were swinging the milk pail. So, say the milk pail is going around in a circle, and it has milk in it, so there's a liquid here. My milk turned out to be blue. And when I swing the milk pail up, and I think